Okay, class, today we are going to learn about solving a system of equations using graphing. Okay, so we have two equations here that would be a system of equations because there's more than one. And these represent position as a function of time. So the position of the car is equal to negative 23 times t for time plus 400. For the first equation. For the second equation, the position of the car is equal to 46 times the time plus 200. So if we go over here to our graph of position over time, the first car, the blue car, starts at 400. So let's say this is 1, 2, 3, 400, and it has a negative slope. So it starts at 400, has a negative slope, so it does something like this. Okay, we're not being exact on this one. We're just thinking very generally here. So the second equation is starts at 200, so 200 here, and it has a positive slope, so it goes up something like this. Now that we have these two graphs on here, you got to think, is there a place where they're at the same position? Well, right here, they're at the same position, and the position where they meet is right there. And do they meet at that position at the same point in time? You can see, yeah, they do. So the solution to that system of equations is the place where their position is the same and the time is the same. So it's a number for x and for y, which in this case represents when, so what point in time, and where, what position. Okay, so for example, here's a more abstract example. It doesn't have context to go with it, but we have two equations, and we can graph them and find a solution for x and y that works for both. Okay, so the first thing we're going to do is take equation 1 and make an xy chart. So we want to find when x is 0, y is negative 4. When y is 0, x is 2. And same thing for equation 2. Find the y-intercept and the x-intercept. Here's what the graph looks like. Now make sure you're writing these down. If you didn't get that last one, rewind a little bit, write down the two equations, the two charts, and graph them both. Okay? Now you're going to want to use graph paper when you graph this, because we need to know where that point is. If you're not using graph paper, it's harder to tell. But once we graph them, the point of intersection is here. And it looks like that point is 1, 2, 3 for x and 1, 2 for y. So it looks like the solution is 3, 2. Now, how can we check that? Let's go back to the equation. Okay. 3, 2 should work for both equations. So 3, 2, 3, 2. And let's check them out and see if they both work. So equation 1, negative 2 times 3 plus 2 equals negative 4. That's negative 6 plus 2 is negative 4. Checks out for the first equation. Now, it doesn't just work for the first equation. It works for both equations. So let's make sure it works for this one. 3 plus 2 equals 5. And it does. It works for the first one and the second one. So that is our solution, 3, 2. Okay. Here's one for you to try. I want you to solve this system of equations by graphing. Y equals 1/2 x minus 2. And y equals negative x plus 1. Remember, our solution is going to be a coordinate pair with an x and a y. When you have your solution, go ahead and enter it into the response system at the top left, the top right of the page.